Hello and welcome to lesson 4.1. We'll be solving quadratic equations graphically today. We'll get right into the warm-up here. So for each quadratic equation listed below, identify a number of things that you should be familiar with by now. Okay, so for this one, the direction of opening, that is indicated by this negative sign on the a value. So this will be down. So this is for quadratic number 1. Coordinates of the vertex are determined by P and Q. And recall that on our P value in the original equation it says A times x minus P all squared plus Q. So since in the equation it says minus, we always have to flip this sign. So the coordinates of the vertex are actually minus 3 and plus 2. Equation of the axis of symmetry, that is always determined by our P value, and it's an equation of a line, right? So it has to have an equal sign in it, and in this case it's always the x value of the vertex, so x equals minus 3. The domain, x values, x is an element of the reals. The range is always determined by your y value of the vertex. In this case it's 2, and this thing opens down, as indicated by this negative sign. So since it starts at 2 and opens down, the range is never going to go above 2. So y, such that y is always less than or equal to 2, but is otherwise an element of the reals. Sketch the graph. So start with our vertex at minus 3 and positive 2 right here. And now we can make our jumps. You can make a table of values. I prefer to use the step method where I go 1 over and then 1a down, 1 over and then 3a down, 1 over and then 5a down, and continuing so on with the odd multiples of a. Here a happens to be 1/2, so we go over 1 and down 1/2. And due to symmetry, there will be another one on the other side just like it. So from here, we then go 3a. So we go over 1 and down 3/2, which is 1.5. So we go over 1 and down 1.5, which will put us right there. And symmetry will put us right there. And then we go over 1 and down 5a, which 5 divided by 2 is 2.5, so we go 1 over and 1, 2.5 down, and symmetry will put us right there. And then you could continue on with that pattern if you wanted and go 7a and 9a. Then we just draw our parabola through the points we've made. Label the x and y intercepts. The x-intercept here, there's going to be 2 of them, and they are at these values that we found, which would be x-intercepts are -5 and 0. Now remember, intercepts we always have to write as entire coordinates. So we need an x value and a y value. Please don't just throw out the 2 numbers like -5 and 1 or -1, because this to me looks like an xy coordinate, and if y is not 0 then it's not an x-intercept. So this is incorrect, and we must ensure that we are including the coordinates of the intercepts correctly. So -1 and 0 is the other x-intercept. So both of these. Your y-intercept, we actually did make a point right here on the y-axis, and it is at the x value is always going to be 0 for a y-intercept, and in this case this was -5/2 was the y value, or -2.5, and you can confirm that by plugging in 0 for x into your equation and then carrying out the rest of the algebra here. So it would look like this: negative 1/2 times 0 plus 3 squared plus 2. So this is 9. So this would end up being negative 9/2 plus 2, negative 9/2 plus 4/2, of course leaves you with negative 5/2, which is what we predicted right here using our step method. Excellent. I'm going to leave the second one up to you to do on your own, and you can come back and unpause it and check for the answers when you're done. Okay, so here are your answers. Hopefully everything looks good. This is the work for completing the square. So we'll move on. Quadratic equations. A quadratic equation is a second-degree equation that can be written ax squared plus bx plus c, where a cannot equal 0. If a is 0, this quadratic term disappears and we have a linear equation. Okay? The solution to the quadratic equation is referred to as the zeros of the equation. You can also find the solution to a quadratic equation by finding its x-intercepts, which are also referred to as zeros. I guess maybe I have one of these wrong. Solution to a quadratic equation is referred to as not sure what I intended to go in that blank. So here we go. Page 209. This is the your turn. If you don't have a graphing calculator, you can just go on to the internet and use Desmos to check it out. But we're just going to simply use a table of values to try to figure out the roots. Oh, that's what it is, the roots. Oops. Yeah, so this would be the roots of the equation. Alright. This one, x squared minus 6x plus 9. Now, using the table of values will usually work. And if it doesn't, then we're going to need to look at different strategies, which we'll be doing in the next section. But for this one, let's try out a few. So when x is 0, this is 0 minus 0 plus 9 equals 0. So when x is 0, y is 9. When x is 1, this would be 1 minus 6 plus 9. So 1 minus 6 is negative 5, plus 9 is 4. When x is 2, this will be 4 minus 12 plus 9. 4 minus 12 is negative 8, plus 9 is positive 1. When x is 3, let's make a little space here. When x is 3, this will be 3 squared, which is 9, minus 18 plus 9. So you find that 9 plus 9 is 18, and then we're subtracting 18, and that'll be 0. That looks more like a 6. There's a 0-ish. Okay, when x is 4, we got 16 minus 24 plus 9. 16 plus 9, of course, is 25. Minus 24 is 1. And 5, we go 25 minus 30, which is negative 5, plus 9 is 4. And you can see in our table of values that we're beginning to see the symmetry, as we always see in quadratics. And you can predict that this will be 9, and we'll verify that here. 6 squared is 36 minus 36, which is 6 times 6, plus 9, of course, leaves us with 9, and that confirms our suspicion. So here we go. When x is 0, y is positive 9. X is 1, y is 4. X is 2, y is 1. X is 3, y is 0. X is 4, y is 1, and you can see that we're going back up on the other side with our symmetry, and you can label those points there. And this is what our parabola looks like, and as you can see, there's only one root because there's only one x-intercept. So the root is going to be x equals 3. This is the only possible value that you can plug in to this equation that will make it true. So this whole thing on the left side is supposed to equal 0, because that's what the equation tells us it equals. And 3 is the only value that will make that actually happen. So 3 is the root of our quadratic. So here's another your turn. We'll go through it together. The manager at Susie's fashion store has determined that the function r of x equals 600 minus 6x squared models the expected weekly revenue. So r, revenue is a function of x from sweatshirts as the price changes, where x is the change in price in dollars. So x is given in dollars and it's the change in price. What price increase or decrease will result in no revenue? So basically, if there's no revenue, this means that r is 0. Okay? This is the revenue function, and if there's no revenue, that revenue function is equal to 0. So we take our function here and we set r of x equal to 0, and then we have to solve for x. Now you can graph this. What I would recommend doing is divide this whole thing by 6. So you divide each term by 6. And it will be 0 equals 100 minus x squared. And we have to figure out what x value will make this statement true. By inspection, if you want this to be 0, then 100 has to be subtracting 100, and therefore x squared must be equal to 100. So x has to be equal to 10. But let's pretend we don't recognize that right away. And you can make a table of values. And of course, start with values that you know the x squareds are going to be close to 100 at least. So let's do 8, 9, 10, 11, 12 and see what happens. If x is 8, we go 8 squared is 64. 100 minus 64 is 36. If x is 9, it's 100 minus 81, which would leave us with 19. If x is 10, it's 100 minus 100, which would leave us with 0. If x is 11, it's 100 minus 121, which would leave us with negative 21. And if x is 12, that's 144. 100 minus 144 would leave us with negative 44. But here you can see that this is clearly going to be our solution. But if you graph this thing, you might find out that there's more than just this one. So let's take a look in Desmos. Now, one thing you may have noticed is that we didn't find symmetry here about this point yet with the ones that we chose, 8, 9, 11, and 12, which means we haven't gone around the vertex to the other side of the parabola. So we need to figure out if there's another 0 somewhere else on the other side of the parabola. So we go 100 minus x squared and zoom out a little bit, and you can see that the 10 that we predicted is correct. But you see that there's another 0 way over here on the other side at minus 10. And this makes sense because if you plug minus 10 into this equation, it's the square of negative 10. And of course, squaring any negative number is going to leave you with positive, so of course we'll end up with 100 minus 100. And your answers then are going to be x can be plus or minus 10. That will fulfill the requirements to make your revenue 0. So if you change the price by adding $10, you'll get 0 revenue, and if you change the price by subtracting $10, so knock $10 off the price, you'll get 0 revenue. You might sell more, but they're probably bringing in 0 revenue per sale. Your turn. Solve this one by graphing. When you come back, I'll have the solution ready for you. Okay, so your first step is to add 2 to both sides. So making one side 0 is always the most important step of solving a quadratic, because we are solving for the zeros of the function. And if you graph this on your graphing calculator on Desmos, you'll find that it actually never crosses the x-axis. There are no x-intercepts, and therefore this quadratic equation is considered prime. Okay, there are no m values that will make this statement true. Alright. Okay, here's your turn from page 213 in your textbook. Give it a try, and we can discuss this one tomorrow. You can plug this into your graphing calculator or into Desmos and see if you can figure out what the horizontal distance would be. This is based on example 4 in your textbook, so all the information is in there, and I'll see you in class tomorrow.